Moving on to part C of Unit 3, which was our killer unit here. This one, we're going to start looking at converting between the different forms as well as graphing. So I'm pretty sure I will probably need 2 videos to get this completed. So that's going to be my goal for this chart. Okay, so starting off, converting between forms. The whole purpose of this is that some of you, once we got to graphing, might have preferred one way over another to graph. So converting between forms allows us to switch between forms. So if you were a person that really liked graphing from Vertex Form, then you could change into Vertex Form, and then you could do the graphing. So this just allows us to go back and forth between the forms. So we had 3 forms: standard form, Intercept Form, and then Vertex Form. So we'll start with standard form. Standard form is ax squared plus bx plus c. When we were in the unit, we made a flip chart for this one. So the steps to get standard form, you need to FOIL, and then distribute, and then combine any like terms if you have them. So here we go, example 1. So convert to standard form. So first thing I'm going to do is FOIL. So I'm going to ignore this -2 out here for just a second. And I'm going to FOIL this together. So if we FOIL x minus 1 with x plus 5, remember FOILing is just distributive property. So we would get x squared plus 5x minus 1x minus 5. So that would give us x squared plus 4x minus 5. So we FOILed those together. That's what we got. Now the next thing that we're going to do is distribute. So now I'm going to include that -2 at the beginning. So to distribute -2 would give me, so I'm going to say y equals -2x squared minus 8x plus 10. All right, example 2. This example I included because we do have a negative out front, which is counting as a -1. So we can put that in there. And then we also do have a like term at the end that we will, combine together. The other reason why I wanted to do this example is because I want you to remember that x plus 2 squared doesn't mean just square the x and the 2. It means that we have to multiply x plus 2 with x plus 2. And then distribute the negative and then subtract the 5. So first up is FOIL. So I'm going to FOIL x plus 2 times x plus 2. Sorry, and again, that's just distributive property. But I'm going to do this one mentally. So I would get x squared outside and inside would add up to 4x, and then last would be plus 4. So now this is what we have. So I'm putting this back inside parentheses because this -5 is not included with this. And if you think about order of operations, we're going to multiply before we subtract. So next thing we need to do is distribute this negative. So we're going to get -x squared minus 4x minus 4 minus 5. And then combine any like terms. So y equals -x squared minus 4x minus 9. So now we have standard form. So standard form was the one that we used to do completing the square. It's also how we factored, although we wouldn't need to because it just was factored. But that takes care of getting, this was Vertex Form. I don't think I pointed that out. This one was Vertex Form, and then this one was Intercept Form. So, hi Maisie. Maisie's making an appearance here. Would you like to speak to the kids? Okay, all right. Now we're on Intercept Form. So Intercept Form is the one that is basically factored form. This is where we could see what the factors are. To get this form, we need to go to standard form first and then factor completely. So again, standard form is pretty important because we always eventually include that somehow. So on this one, this is already in standard form. So that's taken care of. So now what we need to do is factor completely. So first thing when we factor is look for a GCF, but I don't see one. So I am going to use the big X over here. So I need numbers that multiply to be 30 that add up to negative 17. So I'm right away thinking negative 15 and negative 2. Those two would multiply to be 30 and add up to negative 17. And then we divide by the coefficient that we used up in the front. This one can't reduce. This one would reduce to negative 5. So now we can say that if we were to write this in factored form, we would write x minus 5 for this one, and we would write 3x minus 2 for that one. And again, we can always check by multiplying it back together. Number 4, convert to intercept form. This one is starting at vertex form. So again, first thing we have to do if we want intercept form is we need to get standard form. So first I'm going to FOIL x plus 3 squared, which again, that means that we need to multiply x plus 3 times x plus 3 and then subtract 1. So if we FOIL this, we'll get x squared plus, if we do outside and inside, we'll get 6x plus 9. And then we would distribute, but there's nothing in front to distribute, so then we need to subtract 1. So this would give us x squared plus 6x plus 8. All right, that's standard form, but we need to get intercept form. So what we need to do now is to factor this completely. So look for GCF. I don't see one. So now we're looking for numbers that multiply to be 8 that add up to 6. And I'm sure you have that one figured out. So x plus 2 multiplied with x plus 4. And again, we can always check by FOILing. Next up is vertex form. So vertex form is the one that I think we all like the best. This is what it looks like. It's called vertex form because the vertex is right there. Oops. Right there and there, except remember we always change the sign on the one that's with the x. Now, to get this form, what we need to do again is start with standard form. So if we don't have standard form, we need to get standard form, and then we complete the square, almost. So, first example, this is standard form, so we don't have to worry about doing that, but we do need to complete the square. So I'm just going to kind of ignore this f of x for just a minute. So 3 is not the right man for the job over here, so we're going to move him out of the way. So that's going to give us x squared minus 6x plus blank equals negative 3 plus blank. Then this is where we need to think of what the magic number is. So the number that should go in this spot is going to be half of this squared. So half of negative 6 would be negative 3 squared would be 9. All right, so now on this side, now we can factor this. So this would be x minus 3 squared equals 6. And this is where we say we're almost going to complete the square. We're not actually solving this one, though. We're just rewriting it. So what we need to do now is bring the 6 back over. He's coming back to the other side. So f of x equals x minus 3 squared minus 6. And once we have vertex form, now we can see that the vertex of this parabola would be 3, negative 6. All right, example number 8. So convert to vertex form. This is an intercept form. First thing we have to do is get standard form, and then we can complete the square. So first thing, standard form means FOIL. So if we FOIL this together, we'll get x squared. If we do outside plus inside, that would give us 4x minus 21. So now we're going to work on completing the square. 21 is not the right guy, so let's move him out of the way here. So x squared plus 4x plus blank equals 21 plus blank. So now we got to figure out what number do we want to put in this blank right here so that we can factor it. And remember, the way we do that is we take half of this and square it. So half of 4 is 2, 2 squared is 4. And then the rule is whatever you do one side, you have to do the other side. So we keep it balanced. So now this can be factored to be x plus 2 squared. Over here, that equals 25. Again, we're not solving this, we're just converting. So now we want to bring this one back. So f of x is x plus 2 squared minus 25. And so now we can see the vertex of this parabola. Okay, so that takes care of the converting between forms. And since I do have time on this video, I'm going to go ahead and start the graphing, just in case the back takes longer. So if you need to pause and go back or rewind or play again, please do. So I'm going to move on to graphing. So each form can then be graphed. And the way we graph them is slightly different at first, but then it ends up being the same. So the deal is basically, in order to graph a parabola, if you remember, we talked about this, that a parabola is just a U shape. And the deal is we don't know if, so if I use this over here, we don't know if this U shape is over here, up here, over here, over here. It might even be upside down. So what we need to figure out is where the vertex is located, because that vertex will kind of, it's almost like it's nailing down the location of the parabola. So first thing we're going to do, if we are in standard form, is we're going to use negative b over 2a to locate the x value of the vertex, which is also our axis of symmetry. And then in order to get the y, we just, now that we know what x is, we fill it in, work it out. Then we're going to check and see if it's a normal size, and then make the rest of the points from there. So here we go. First up. So this is definitely standard form right here. So in order to find the vertex, we need to do negative b over 2a. So negative b would be negative 6 over 2a is going to be 2, so that equals negative 3. So we know our vertex is negative 3 something. So now we know what x is, let's fill it in. So to figure out what y is, all right, now remember that even though there's nothing in front of this, it's just a 1, we always square. Exponents come before multiplying. So we're going to square first. So negative 3 squared is going to be 9. 6 times negative 3 is negative 18, and then plus 7. So if we work this out, that's going to be negative 9 plus 7 should be negative 2. So now we know the location of our vertex. So let's go ahead and come over here. Our vertex is negative 3, negative 2. Okay, so let's talk about what we know for this parabola. So there's our vertex. We know that the axis of symmetry is x equals negative 3, because it's a vertical line. So we can go ahead and graph that on there. Now, what we're going to do next is look at the value of the a, which remember is the leading coefficient right there. And hopefully you remember that that a tells us if it's a normal size or if we're going to shrink or stretch the parabola. So this one is just a normal size. So remember that what we're doing is basically just moving over and squaring to go up. So we go over 1, we go up 1, and we can put a point. If we go over 2, we square that, we go up 4. If we go over 3, that means we're going to go up 9. And that looks like that's all that we can do for this parabola. And then that axis of symmetry is a mirror, so we know that we have the points on this side as well. And now we're good to go. And look, it's a parabola, dear. All right, so there's our graphed parabola using standard form. So I'm at the end of this video, so we'll continue with the back on part 2.